welcome back to the third episode of Genes with JoJo. Now that we have learned what DNA is and how it is made, we will learn about heredity and the two forms of a gene. Heredity is the passing of genetic information from DNA from one generation to the next.
What this means for us is that all of our genes have been passed from our parents to us. This is why you look something like a combination of both of your biological parents. For example, I have freckles and brown eyes like my mom, but have dark blonde hair like my dad. Well, like my dad used to.
The concept of heredity is also why siblings tend to look very similar, because they share many of the same genes because they have the same parents. This is my little sister, and we both have freckles, blonde hair, and brown eyes. At this point you might be thinking, wait, if my genes are a combination of my parents, and my brother or sister genes are a combination of our parents, why don't we look exactly similar? Are we not actually siblings? Before you start to panic, let me explain the two forms of genes.
With every organism that has two parents, like people, there are two copies of each gene, one copy from the father and one copy from the mother. Each of these genes can either be dominant or recessive. If a dominant gene is present, it will cover up a recessive gene, so the only way to get a recessive gene to show is if the offspring has two copies of the recessive gene.
For an example, let's look at the classic example of eye color. While many genes actually contribute to eye color, let's pretend for this example that only one gene controls the color of your eyes.
The gene for brown eyes is dominant to the gene for blue eyes. Dominant genes are written as capital letters, while recessive genes are written as the same lowercase letter. For eye color, that would be capital B brown and lowercase b blue. If Billy here has two copies of the dominant brown eye gene, his eyes will be brown because that is the only type of gene for eye color he has. If Billy has two copies of the recessive blue eye gene, he will have blue eyes because there is no dominant brown gene to cover up the blue gene. If Billy has one copy of the brown eye gene and one copy of the blue eye gene, his eyes will be brown because the dominant brown color gene will hide the recessive blue color gene. So to recap, if a dominant version of a gene is present, it will cover up the recessive version.
If you are thinking, that makes sense, but that doesn't explain why I look different than my sibling, allow me to explain.
When your parents combine their DNA to make you, they do not get to choose which copy of their genes they give to you. It is completely random. This random combining is also the same for your sibling.
For example, give me a thumbs up and look at the top of your thumb. Most people like me will have a straight thumb, but some people will have a bend at the top of their thumb, which is known as hitchhiker's thumb. Straight thumbs are dominant to hitchhiker's thumbs.
My sister Sam has hitchhiker's thumbs, which means that she has two copies of the recessive hitchhiker's thumb gene, while I have one copy of the straight thumb and one copy of hitchhiker's thumb. This is just one example of how the random way in which we get our genes from our parents can lead to us looking a bit different from our siblings.
For a fun activity, let's try to find out some of your genotypes based on your parents' phenotypes.
All you need is a piece of paper, a straight edge, and something to write with. First, we will need to make a chart, so let's fold our paper into 16 squares. Now let's label the axes of our chart. For the top, we will write trait, key, potential genotype, and my genotype. Now let's label the side of our chart with the 3 different genes we will investigate today. They are eye color, type of thumb, and freckles. For our next column over, we will be making a key for our genotype chart to show the 2 different forms of the gene. For eye color, capital B brown is dominant to lowercase blue. If you have green eyes or any other color of eyes besides brown, it is a recessive gene. For thumbs, capital T straight thumbs are dominant to lowercase t hitchhiker's thumbs. For freckles, capital F is the sign for freckles. Lowercase f is the sign for no freckles. And yes, I accidentally did mix those two up on this chart. Now we are going to fill out the potential genotype row. A genotype is basically two letters used to describe the combination of genes somebody has for a particular trait. For example, I have brown eyes, so I could have a genotype of capital B, or capital B, lowercase b. If you have blue eyes or another color, you can only have two recessive genes, being lowercase b, lowercase b. For thumb type, I have a straight thumb, so my genotype could be capital T, lowercase t, or capital T, capital T. Finally, for the freckle trait, I do have freckles, so my genotype can either be capital F, lowercase f, or capital F, capital F. Sorry again for the mix-up on my sheet. Our last step is to go find out what our parents have to see what combination of genes we have. I will show you my investigation for eye color. My mom has brown eyes, so she could give me a capital B or a lowercase b. But my dad has blue eyes, so he can only give me a recessive lowercase b. That means for eye color, I have capital B, lowercase b. Try and fill out the rest of the chart on your own. You can even add more categories if you want. So that's it for now. Have a great day and see you next time on Genes with JoJo.